Okay, we have already talked about maximization of the profit. Now we are going to talk about maximization of the revenue, right? Now the thing that you have to remember that revenue will be maximized when the marginal revenue is equal to zero. That's what you have to remember. Now I've given you a small example. If you see here, um, here is the price, quantity, total revenue, and marginal revenue. Marginal revenue, which means that the revenue from selling one more unit. So let's say, for example, we are selling something for $10 and we can sell one unit. The quantity is one. So the revenue will be 10 multiplied by one, which is 10. Okay. Now, if you reduce the price, you will be able to sell more units. So let's say the price is reduced from 10 to 9. So now you can sell two units. So the total revenue is 8. And the additional revenue, previously you had 10 and now you have 18. So the additional revenue is 8, which is the marginal revenue. If you further reduce the selling price from 9 to 8, now you can sell 3 units and the total revenue is 24 and the additional revenue is going to be 6. The marginal revenue is 6. If you further reduce it to 7, now you can sell 4 units. So the total revenue is 28 and the marginal revenue is 4. Can you see that the marginal revenue continuously is reducing? Okay. Similarly, if you can sell it for a price of $6, now you'll be able to sell, let's say, one more unit. You can sell now 5 units. So the total revenue will be 30 and the marginal revenue is 2, right? So from the additional unit, because you are reducing the price, so the marginal revenue is reducing, right? And if the price is 5, now the marginal revenue is 0. Can you see? For 6, when the price was 6, it was 30. When the price is 5, it's still 30, right? So no additional unit. If you further reduce the price, right, the marginal revenue will be in negative, right? Now, if you want to maximize your revenue, this is the point where you are going to stop, right? If you further reduce the price, your revenue will be less. If you increase the price, right, your revenue will not be maximized either, right? So the the revenue will be maximized when your marginal revenue is equal to 0. That's what you have to remember now. Now we have an example here. We'll be still following our three-step approach for this question also. It says the demand curve of a product P is equal to 24 minus 0.004 Q. Well, that's P is equal to A minus BQ. That's basically our demand equation, where A is the price at which demand is 0, right? And B is the gradient, okay? Now, it means that the maximum price will be 24 and B will be 0.004. At the current, the selling price is $10. So this is the current selling price and the current demand is 3,500 units, right? So here is the current price and the current demand, right? By how much could the company raise the selling price per unit in order to increase the total sales revenue per week, right? So we want to see that what should be the selling price to maximize our revenue, right? Now, step number one, we'll start with the demand equation, right? Which is given to us already, okay? So which is P is equal to A minus BQ. So we are going to write P is equal to 24 minus 0.004 Q. Step number two, we'll say revenue will be maximized when the marginal revenue is equal to 0. Now we know that the equation for the marginal revenue is A minus 2BQ. So A minus 2BQ is equal to 0, right? A is 24, so 24 minus 2 multiply by B, which is 0.004 Q, right? Now we are going to find the value of Q. Now, 24 will move to the other side of the equation, so that will become minus 24, and this thing will become 2 multiplied by 0.004, which is 0.008. This basically means 0.008, 3 decimal places to the left, right? So this will become minus 0.008 Q is equal to, and 24 will move to the other side of the equation, so this will become minus 24. So Q will be equal to minus 24 divided by minus 0.008. So 24 divided by 0.008 will give you 3000. This basically means that the revenue will be maximized when the quantity is 3000. Revenue is maximum when quantity is 3000 units. Now, all we have to do in the third step, we actually have to find the selling price at these many units. So step number 3, we are going to use the demand equation once again. P is equal to A minus B Q, right? So we have to find the value of P now. P is equal to A, which is 24, minus B, which is 0.004, and the quantity is 3000. So this will be 3000 multiplied by 0.004, which will be 12. 24 minus 12 will be 12. So price should be 12, right? Now, if you see the requirement, or let's write it down first. Revenue is maximum when price is equal to $12. Okay. Now, what is the requirement? The requirement says by how much could the company raise the selling price, right? Remember, the current selling price is 10, and the revenue will be maximized when it is 12, which means that if the selling price is increased by 2, the revenue will be maximized. Okay. So that's how you basically calculate the maximization of the revenue. I just gave you this example so that you can understand it well. All you have to remember in your examination is that revenue will be maximized when marginal revenue is equal to 0, right? For the profit maximization, it was different. Profit will be maximized when the marginal revenue is equal to the marginal cost. Revenue will be maximized when the marginal revenue is equal to 0. Okay.